Okay, it's
Okay.
working now.
Okay.
Okay, thank you very much. So today we are going to continue from where we left off. The last time there were some few things we needed to wrap up with, and then we'll move to concluding on what we started. So I'm going to share my screen with you briefly, and we are going to set the ball rolling. Sir, Dr. Mills.
Oh, sorry. I didn't do the multiple.
Yes.
Okay. It's done. It's done. Sorry.
Okay.
Yeah.
Okay. So I think last week we we were at this particular point where we were doing the exploratory data analysis, and we went to generating data generation for ML model, and we were trying to build our own use case of a problem and see how we can generate some data. Today we are quickly going to do that, and then we'll move on to some data preparation processes. It is not going to be exhaustive. At least we are going to cover the ones we need for now. As and when it becomes necessary to learn other concepts, we're also going to learn them, and some finding class imbalance, and then data visualization, and then some few things, data encoding for pre-processing and all that. So hopefully we'll be able to cover a lot today. So let me just create a folder. I think this was what we were using the last time, data analysis. So let me just open up my Jupyter Notebook environment over here. So guided by this, let's complete what we have here with the data generation, because we started that last weekend. I just want us to finish that one. So what we have over here is, let me create a new workbook. So what we have over here is we are going to continue with our function, and we are going to build it in blocks. Okay, so the first thing I want to do whenever I'm doing anything is at least have some kind of a model that works. Okay, then later on we can fine tune the model and we can perfect it. Okay, so now let's just create something or write a function that generates data, and then we'll put in those checks and balances to make sure that even though it is randomly generated, but then it is conforming to some of the parameters that you are setting for yourself. Because, for instance, we want to have a situation where the size of mango is not going to be bigger than the size of watermelon. Okay, I mean the average mature size of a mango not bigger than the average mature size of a watermelon. So last week we started with I think let's import numpy as np over here, and then I think we also imported random to get this going. So at least for now we will need this. Let me also import pandas, because I'm looking at the bigger picture. PD. So we have these three imports, and this is what we are going to work with. So we were creating a function, and we called this function generate data. And then the question we were asking ourselves was, okay, what's going to be the size of this data? So whenever we are calling this function, we are going to pass in a parameter size over there. And that size is going to tell the function the number of instances to generate. So maybe if we specify size as 100, that means we want 100 different fruits, stuff like that. So over here, I'm going to have a data, which is going to be an empty list, because I'm thinking of doing some appending as we move along. And now I'm going to run a for loop over here. So I'm going to say for, and I'm just going to put an underscore over here just to get a variable that I really don't want to use, but then I need this in order to loop through the size. So I can say for whatever thing we see over there in range, and I pass in size over here. Now this is where I can be writing some few things over here. So let's say I have fruits. So the fruit name, let me call this fruit name. And now let me come back here and I'll do a fruit list. So I'll do fruits underscore list over here. And the ones that we're working with, I think we had mango, we settled on mango, and then we had pineapple. Let's do orange. And then let's do, I think I just brought in watermelon. So let's do watermelon. Is it together or this way? Okay. So this is the fruit list. So I'm going to say the fruit name is going to be NP, which is, random dots. And this one I can use choices over here. So I can use choice. And then I just want to randomly select from this fruit list as I have over here. So that one is going to be for this fruit name. Now, the next parameter I want to look at is the weight. So I'm going to say the weight is also going to be random dots. And we are looking at the weight in terms of, let's say, grams or kilograms or whatever. Okay. But then I think grams is okay. So that one can be uniform because uniform is going to give us that floating point value. So I can say uniform, and now I specify my lower bound and my upper bound, or my lower limit and my upper limit. So let's say the least I want to have is, let's say, a 0.2, and the highest I'm thinking of is maybe a 5.0. So this is what weight is going to constitute. Okay. Then I think the other one that we were looking at was, I think, the color. So once again, let's have a color list. And then for the color, let's say we have green, and then we have yellow, and then we have orange, and then let's have, okay, I think the other time we're using pear, and pear was giving us brown. Other than that, most of them are going to be green and yellow, green and yellow. So let's replace this with pear so that at least we have that unique brown over here. Okay. So over here too, I can see the color is going to be equal to, and I'm going to say random dots choice, like we studied the last time. And then the choices I want is from this color list. So everything looks good over here. Then I think we also spoke about the acidity and the, is it Brix? Okay. So let's look at the acidity. And acidity, I'm also looking at random dots. And over here too, I'm going to use uniform. But we, knowing the little chemistry that we took from secondary school, we know that acidity has a range, okay? And if we go beyond 7, then that means we are not too acidic enough, okay? So for the purpose of this, the acid concentration can also be too high. I mean, it cannot be something that's, I mean, these are fruits, we eat them, they contain acid, but then those acids are very low. So I think probably we can be looking at, I'm not too sure, but maybe between 5 and let's say 7. So any of these range, I think it is edible acid. I mean, I may be wrong, but then for the purpose of this argument, let's just maintain this one. And then the last one our brother brought was Brix, which he said was had to do with the sweetness. Okay. So let's say we have random dots, also a uniform over there. Now, if you remember very well, we can do those things right away because the uniform is going to give us something with a very high decimal place, okay, about 7 or so. So we can be doing the rounding up over here to maybe 2 decimal places so that our data is not too big in terms of whatever thing we have. So let's say we round this up to 2 decimal places, and we do same over here. So let me just copy this to another 2 decimal places. Let me copy this as well to 2 decimal places. and then copy this to also 2 decimal places. But then let me not forget about the values we put over here. Derek, please can you share with us maybe a comfortable range in terms of the sweetness, because we don't know so much about Brix.
Okay, so we can do like 5 to 14.
5 to 14. Okay, thank you very much. So he's a food process engineer, so he knows what he's saying. So we have this, and based on what we know from the random module that we learned last week, we should definitely be comfortable with the code that we have written so far. But then the only thing we have introduced here now is we are just putting everything in a function. Now we have an empty list over here. And remember, with a list, we can be doing some appending. So over here, what I'm going to do is I'm going to do data.append. And what do I want to append? I want to append this, and I'm going to put this in a list. So I'm going to put the fruit name over here. Then I'll do a comma. Then I'll put the weight as well. Control C, Control V. Then a comma. Then I'll put the color as well. Control C. I think I'll run into some problems over here because the color is going to be from choices.
The color is not.
Exactly. So we cannot be rounding things up over here. Okay. I think we're carried away. So we have color. Then let's look at the acidity. I can copy this and also put acidity over here. And then let me also copy Brix and put that over here as well. So basically, based on the number of size that we will specify, when we call this generate data function, if you put 10 over here, that means it's going to run this loop 10 times. And upon each iteration, it's going to select a random choice from this list or fruit list as we have over here. Then it is also going to select or going to pick one random uniform value, which is going to be a floating point value between a 0.2 and a 0.5, but then it will round it up to 2 decimal places and assign it as its corresponding weight. And it will do same for color, same for acidity and the other ones. Then after everything, we do an append into the empty list as we have over here. So now that we have this, now I can come back out of this loop and let's say return data. Okay, so now that we have returned data, we can run this and we don't seem to have any problem for now. So now let's just call this function. And let's say we pass in 10 over here. So when I run this, indeed we get 10 random selections as we have specified over here. So on the first row, we have pineapple, and then a 0.5, a yellow, and then in terms of this one was the acidity. Okay, in terms of the acidity, we have a 6.37, and also for the Brix, which has to do with the sweetness, we have a 12.19. Okay, but then remember what I said previously. For instance, we're having issues where a typical orange, okay, is bigger than a typical pineapple in terms of the size. The weight. Okay, the first attribute you have over here is the weight. So this is why we need to be a little bit minded. But then my problem for now is not even with this, okay? But then let me save this in a variable called database. And now let's do some analysis over here. So we have data and everything is looking good. But then you agree with me that if we decide to do some computation with this data as we have it over here, then we are going to run into problems. Because for instance, if I'm to check the data type of data, it is telling me that this is a list. We cannot even do multiplication with list, okay? So we need to convert this into a NumPy array. And that's the reason why I have NumPy imported over here. So what I'm going to do, and it's just basically going to do a typecasting because we already have everything structured out. They just missing this one. I'll come here. So I'll come back here and I'll say data is going to be equal to np.array. And what do I want to pass in as the array? I want to pass in this data. So remember the dynamic nature of Python, we can override data and stuff like that. Okay. So this data originally is what I'm picking up over here and doing the appending. And now I come outside of the loop and I'll say this data, once again, I'm overwriting that data and I'm saying numpy dot array. So I'm typecasting originally whatever thing we have over here as a list into a numpy array. So with this modification, if I run this, and I'll come back to come and run this, now we get a proper sense of a data that we can work with. We can do some computations around, because over here we can see that we have an array over here and we clearly see the data type showing up over here. Now, if I'm to do a type of this data as we have it over here, it clearly tells me that this is a numpy array. So now we can do those computations that we know. Okay, so this is going to solve part of the problem, okay? The other part of the problem is a lot more technical, and that's why we are trying to wear our engineering hats to be modeling things around its natural state, okay, how it is naturally going to look like. And this is where Dr. Mills always emphasized that, yes, your knowledge of computer engineering or programming or machine learning is not going to solve all the problems you will encounter. You also need some experts to guide you. So based on what we decided on, we realized that the fruits, and this is how I want us to think about it, okay? This approach may work for this one, but then for some data generation processes, it may be a little bit different. We just have to understand precisely what we are dealing with, okay? Now, I believe the type of fruit, okay, has a ripple effect on the color, okay? Also has a direct effect on the weight, the acidity, and also the Brix, which is what we've come to understand as the sweetness of it. So what we can say, okay, then we can use the type of fruit to actually measure our step in terms of what we select randomly. Good. So over here, what I'm going to do is, yes, we are going to select the fruit randomly. Then we are going to write some if-else statements based on the particular fruit we select. So what I'm going to say is, okay, so if the fruit name, which has been selected randomly, is equal to, and now we can specifically, for instance, enter, let's say, mango, okay? If the fruit selected is equal to, but then what I'm going to do is I'm just going to be a little bit technical over here. So I'm just going to bring the fruit list. So if the fruit name is equal to this, and I'm going to pass the index. So clearly we know that the index is going to make this mango. Is that okay? So we are saying that if this is mango, then what we want to do is, okay, let me indent these ones and bring the semicolon over here. I mean the colon over here. So if the fruit name is, what I see is mango based on the selection we have made over here, then the weight, this is where we now specify the parameters to some specific values. And then I can do an elif statement over here. So I'm going to say elif, and let me just clean this up over here. Elif, if the fruit is equal to, and now I'm putting one over here, which is going to be pineapple, then I'll modify the things I want over here to conform to the parameters I've set for myself, or maybe the expert is telling me. And once again, let me do this. So I'm just copying and pasting, and later we are going to specify our own interesting values. So I'm going to put 2 over here, and this 2 is going to this. So this is going to be 0, 1, 2. So 2 is going to be orange. And then finally, let's have one for, I think, pear. So pear is going to be 3 over here. And that's the end of our list. So you have 0, 1, 2, 3. Okay, good. So now I'm saying that if the fruit name that is randomly selected over here from random.choices and from this fruit list, if it is 0, which is mango, then all that I want is, okay, I want the weight to be of a particular range. So now let's work this out. So let's say for mango, among all these fruits, I think mango and orange are probably going to be the low values over here, or the low hanging fruits, if you want to be that way. So now let's say I want to have something between a 0.2 and let's say a 3.0. I don't want to go beyond that. Okay. So this one looks good. And then what about the color? Okay. At least if it is mango, I'm expecting to see, let's say, something like something in an orange color or maybe in a green color or maybe yellow, depending on what you want to choose. Okay. So over here, please help me. Which one do we go for? If it is mango, what are the color options that we have? I just want us to have 2 each for everyone. Do we go for orange and yellow or orange and green or yellow and green? Okay, somebody
Yellow
says
and green.
yellow and green. Okay, so let's go for yellow and green over here. So over here, I can be a little bit specific over here, and I'll just type it over here. So I'll say yellow, comma green, or I can be doing the slicing over here, but that may look a little bit confusing for some people. So I'm just keeping it simple over here. Okay, then the acidity. I think among all the fruits we have over, I think orange is going to be the most acidic. And then probably maybe followed by pineapple, before mango, and maybe pear. That's my thinking. Do we all agree to that? So let's build consensus. So maybe somebody has tasted a pear that was so much acidic. Do we go? Okay, so if that being the case, then I think for acidity, so in terms of acidity, I'm saying this is ranking number 1, followed by this 2, then 3, and then 4. So now we are dealing with mango. So mango is like going to be on the basic end or getting to the neutral or maybe So I think this one we can do, let's say, a 6.5 to a 7 for the acidity over here. Now, in terms of the breaks, I think pineapple, the sweetness is going to be between, this one too is very contentious, so it depends on, but I think pineapple is very sweet, maybe followed by mango and then orange. In fact, let's not argue about this, but then let's assume pineapple is the sweetest over here. So over here, followed by mango. So if that's the case, Derek, please, can you help us with the breaks? Is it the higher you are to 14, that's sweeter, or the lower you are to 5, that's sweeter?
The higher you are.
Okay, the higher you are. So let's say we give this ranging from 10 to 14. Okay, so this one looks good for us. Now we come to the pineapple. And like I said, I'm thinking of pineapple being the sweetest. So for pineapple, I'm going to go starting from 12 in terms of the breaks. Okay, 12 to 14. And then for the acidity, I think pineapple is right after orange. So if orange was, okay, right after orange, so mango was like the midpoint. And then for the acidity, we're looking at, I mean, it cannot be too acidic. We cannot go 4 to, that one is like very high concentration of acid. So let's say we can do, let's say, a 5.5 over here to maybe x6.5. Okay. Then the color, what are the colors that we can think for pineapple? I think we can go with green and yellow. Okay, so I think yellow and green is also good over here. So yellow and green. And then finally, wheat. Okay, pineapple, I believe, is going to be of the highest wheat value. So let's start with, let's say, a 3.5 to the 5.0, because that's going to be the heaviest. Now we go to orange. I think orange, let's start with the color, because for orange, we can clearly see that for the color list, let's do with orange and yellow. So we can have orange and then yellow over here for the color. And then when it comes to the, how do you call it? The acidity, orange is going to be one of the least. So let's say 5 points this to, let's say, a 5.4. And then in terms of the breaks, I think it's going to come right after pineapple. Pineapple is between 12 and 4. So let's say we can have this as between let's say 10.5 and then 12.2. Okay, now finally let's go to pair. So pair for the colors, I can look at very quickly. I think this one is the only one that's going to have brown over here. So I can look at brown and then I think maybe green. And then in terms of acidity, I'll keep it here, which is not too acidic, or maybe a 6.3. Okay, because the lower we get, the more acidic we become. And then in terms of the breaks, this one too, I think I'll keep it on the low because we don't have a lot of sweetness in pear. So like my brother rightly said, the lower we are to 5, then that means the less sweet we are. So over here, let's say between 5 and 7 will be okay. Any floating point value within this range. And I think in terms of the weight, I didn't talk about the weight over here. We'll come back to the weight of pineapple. But then the weight of pear is also going to be, if I'm to look at this, I think it's going to come right after pineapple. So over here, okay, I think this one is for orange. Okay, so orange is, I think it's okay. Orange between this. So orange is going to be the least. Okay, so between this and let's say a 2.0 is okay. Then pear is right after pineapple. So this is pineapple, and pineapple is going to be number 1. So pineapple over here was, the weight was 3.5 to 5.0. So let's do a 2.6, a 2.6, a 2.6 to, let's say, a 4.0. Okay, so these are just some intelligent guesses that we've all come to agree with. So now let's run this and everything is looking good. So now let's generate some random data and now let's print this out as we have over here. So clearly things are beginning to make sense to me in a sense that yes, we have mango, and clearly the mango of this is the first one you have over here is the size, the weight. So the weight of mango is never going to be bigger than the weight of pear. Okay, so mangoes are the smallest we have over here, and oranges are within the range of mango. Okay, pears are a little bit bigger, and then pineapple is looking much bigger over here, and then mango is small. So at least this one will make a very good data that we can generate. But then the key thing is generating this is definitely not going to end here. Depending on the new information that you get, you can modify the code that we have over here. So I'm going to share this with you, and I'm quickly going to run through some few things. So now we've come to a point where we're able to generate this data. Let's look at some few things over here quickly because our time is almost gone. So in the next 15 minutes, I'll try as much as I can to handle at least the data. Let me see. Okay, let's look at the data encoding for pre-processing because that's very important. Now, you recall that, and hopefully on Thursday, I'm going to touch on this extensively. You recall that whenever we are dealing with, for instance, our, how do you call it? The neural network, okay, we said it is going to be our input, okay, so our X multiplied by our weight, okay, then plus a potential bias, and we'll pass it through an activation function. And if we have, for instance, data that is not, because remember, this is going to be some multiplication. So the data that we can multiply are either ints or floats. All right. So if we have something like green, definitely we cannot multiply green by a 0.33. Okay, we can also multiply yellow by 11.44 or any other number. So in a lot of instances, we would want to change these, how do you call it, textual data or string data into some categorical data. When we say we are changing this into categorical data, all that we are trying to say is, okay, we don't want to do it manually. Okay, there are functions in here or libraries that can help us do that. So what that we want is, okay, we want to kind of have the data. If, for instance, we are representing all the greens with 0, and maybe all the browns with 1, all the yellows with 2, all the oranges with 3, that kind of logic, so that it automatically changes it for us. Okay, so we are going to look at that very soon. But then let me also show you something. We see that there's an NumPy array, and maybe for some reason, we may want to have this in a data frame so that we have some kind of a structure, and we can apply some of the methods we have with pandas on that particular data frame. Okay, so over here we can do, let's say, create a new variable. I'm going to call this data set is going to be equal to PD. Remember, I've already imported pandas over here as PD, so I can call it over here. So I can say PD dot data frame. We saw this a couple of weeks ago. And then what do I pass? I pass in data, because this data is this NumPy array over here. So when I run this, I don't seem to have any problem. Now let me do a preview of this data set, and certainly I have that kind of a structure. Now I can put in my column names. Okay, I hope you remember. So I can pass in the columns attribute over here, and this is going to be a list. So the first one I have is the fruits. Okay, so I'm going to pass in fruits. The second element I have over here, I believe, is the weight. I'll go and check. Then after weight, I have the fruit name, the weight, the color, acidity. So color, acidity. So I have color, acidity. So I can put in color over here, and then acidity. And then finally, I have the bricks. Okay, so I'll run this, and then I'll run this as well. And now everything is looking perfect, like the way we want our data set to look like in a pandas data frame. And of course, now the key thing I want to show is, now that we have this data set properly lined up, I can now do the info and the other things that we saw. So I can do info, and when I do info, I get to see that, okay, we have a range between we have 10 entries between 0 and 9. That's based on the indexing counting. And then we see that these are the columns and these are the non-null values. So everything is filled up over here, and everything is looking good in terms of what we see over here. Now I can also do the data sets dot the correlation. Maybe for some reason you may want to have, okay, so we have and this is where changing things into categorical data sets will help you, because for correlation, we cannot be mixing strings with floats or numbers, okay? So we want to make sure that everything is some kind of a numerical value in here. So we can actually work on that. And that's what I'm going to briefly touch on. So we've been able to, first of all, we started with the random generation, writing a function. We did the first one. We then modified it to actually make sense from some expert opinion that we all came to align with. We converted it into a NumPy array, and then we've even converted it into a data frame or a pandas data frame, so that it makes a lot of sense in some of the analysis that we want to do. So let me quickly go to the point that I want to make over here with the data encoding for pre-processing. And over here, we are going to use a library called scikit-learn. Now, this scikit-learn is a very big library. Okay, it contains majority of the libraries we are going to use for our machine learning model development. So all the algorithms you've heard of, decision tree, random forest, SVM, and most of the things are in here. So we are going to learn this extensively. Now, in order to get this scikit-learn, we can come in here. No, I think so. Let's get here first. So yeah, I think there's a library. I mean, the official website, and there are lots of things we can do over here. I mean, a lot of people use this for a lot of development. So it says the scikit-learn development and maintenance are financed by, and we see Microsoft, NVIDIA, and some big companies over here. Okay, so definitely it is a very big library. Now, one thing I find very interesting with scikit-learn is if you are installing this, okay, let's see how this one is done because it looks very funny and interesting. Let me just go to pypy.org where we can get all the libraries. Okay, so I'll type in scikit-learn this way, and then we have this showing up over here. So I think the latest update was 11 September, okay, a few days ago, 2024. So I mean, they keep working on it. So in order to install this, we do a pip install scikit-learn this way. So you just copy this and run it in your terminal, okay? Or because you are using this Jupyter Notebook environment, I can still run it over here and it's going to work. So if you don't have this, you just go through this process. But then I already have it, so I'm not going to bother myself do that again. So when I do a pip list, you can do this in your terminal as well. If I'm to do a pip list, I mean, I get to see all the packages and libraries I have over here. Now, interestingly, when scikit-learn installs on your system, the name changes. I don't know why, but then the name changes from scikit-learn to what we see over here. Okay, so we have scikit-learn showing up over here. Good. So there's scikit-learn. But interestingly, if I'm to come in here and try using scikit-learn, so import scikit-learn and run this, it tells me there's a problem. And it is a problem because if you are using it, it is no longer scikit-learn, but then the name changes to sklearn. So you see a lot of import sklearn. And now when I do import sklearn, everything works. So the name, if you are working with it, is sklearn. So over here, you are going to use scikit-learn, and it has a lot of libraries and methods. Now, the interesting thing to note is that scikit-learn also has some data sets in there. So let me show you. So I can say from scikit-learn import data sets with an S over here. So when I run this, everything looks good. So now see what I'm going to do. I'm going to say data sets, this I'm calling over here dots, and I'm going to say load underscore iris. This is going to give us the iris data set. So let me save this in a variable called data. And now when I run this, everything looks good. And now when I do a control C and a control V of this data, that is an object from this loading or calling this method out of this data set. Okay. When I run this shift enter, we get the iris data set. But then things have been shipped up a little bit. Now, the first one we looked at was the one that had I mean, what in a CSV file format that we downloaded, and we looked at we imported it as a data frame and looked at some few things. But then this one, who can tell me the data type you see over here just by looking at this? Okay, what data type do you think this is? Anybody can share with us? What data type do you think this is structured in? Oh, we can normally tell a data type by just looking at it. Okay, somebody has something in the chat. Okay, Mariama says a dictionary. Well, that's a good one. Okay, it looks like a dictionary. Okay, it behaves like a dictionary, but then there's a few technicalities to it. But then for now, we'll take a dictionary because actually, you see the declaration over here. Okay, there's a curly bracket, and these are the keys. So we have the keys over here, and its corresponding data is what we have as this NumPy array. So this NumPy array is like the sepal length, the sepal width, petal length, petal width. And then when we scroll down, we get a little bit more information. So you see, we have targets over here. And inside of this target, you could see that we have an array of 0, 0, 0, 0, 0, 0. I think about 50 of them. Then 1, 1, 1, 1, 1, 1, about 50 of them. And then 2, 2, 2, 2, 2, 2. So that's the target. And now the target name. So these are the actual names. So here we have Iris setosa, Iris versicolor, and Iris virginica. And this is exactly what we have from our data set. Let me try and see if I can locate that data set for us to see. I think that was in the pandas. Pandas, that will be on my desktop. Good. So this is the Iris data sets, the original one we downloaded. Good. So over here, we can clearly see that, well, these were the labels, okay? So you see that the first 50, and let's just count by the rows that we have over here. So clearly the first one is just occupying the column name. So we are starting from 2 over here, okay? So we start with 2, we scroll down to about 51. So this 15, or okay, 51. This 15. So the first 50 rows, or the first 50 are all Iris setosa, followed by Iris versicolor and then Iris virginica. And that's exactly what we see over here. So the first 50 is Iris setosa, then Iris versicolor and Iris virginica. And these have been given categorical labels. This is what I'm referring to. They've been given categorical labels. So it is not, the system is not going to see it just Iris setosa, but then it's going to look at it as 0 or 1 or 2. And then eventually, when we start building our models, we are going to see the relevance of this, why we need to change some data into some categorical data. And then we have the description, and then we have the feature names, okay? Now I have something interesting that I'm going to show you later on. So now, if, for instance, maybe I just want to grab the data, okay, the actual data itself, I just grab it by the key. So now the data is data. Now, if I'm to do data and do a slicing, because that's how I grab, how do you call it, data from dictionaries, okay? If I'm to do this, and let's say call this X, and if I'm to do a preview of X, I get just the data, okay? Just the data of this. So if you are typically building a machine learning model, this X is going to be our inputs, and then our Y, which is going to be the classes or categories, is going to be the targets. So now I can do Y is now going to be equal to data. The data is going to be the original. Then I do a slicing and get a target. Then now when I run this, I get this 0, 0, 0, 0, 1, 1, 1, 1, 1, and 2, 2, 2, 2, 2. This is almost like slicing this into 3 pieces, okay, and changing them into some categorical data. Okay. So having said that, there's one last thing I need to show before we close, because we don't have a lot of time. Now, the last thing is, okay, this data is some kind of pre-processed for us, okay? And I've actually done some modification on my KBTCal, my library, okay? And the reason why I did this was for, of course, teaching and demonstration purposes, but then I also want to kind of inspire students that some of these things are not rocket science, okay? Like we have with the scikit-learn, because later on we are going to see that scikit-learn has a lot of things far beyond this data set that we are even grabbing from the Iris, okay? Now, what I have over here is I've done a modification, and I did it, I mean, today, okay? Just this morning, 17th September 2024. So with this modification, I've added, I said, this version of the library contains dummy data sets, okay? And I've named this CPen and FPen for learning and demonstration purposes. So, of course, if you already have installed KBTCal previously, you are still going to have that old library. So now you can do an upgrade of this, okay? And in order to do the upgrade, you simply have to go into your terminal and type in pip install -- double dash, okay? Then you do upgrade and the name of the library, KBTCal, this way. And it will get the new version for you. So I think the previous version was version 1.3, and the new one I have over here is version 1.5. I want you to do this so that you get to see some of these things. Now, what I did was, okay, in order for our learners, participants of this program to appreciate and understand that this library contains a lot of things. Yes, so now I'm going to say from, let's say, KBTCal, I want to import data set. Now I modeled my own just like the way I mean scikit-learn is also modeling its own. So from sklearn import data sets and you get that data set. And what I did was this data set dot load iris. Now this is iris. That's why it is given that function name. Now in my case, I'm going to run this. Now I'm going to say data set dot, and my function over there is load, for instance, let's say fpen. So when I say load fpen, let me save this in a variable called x. Now when I do a preview of x, I get this data. And just as we saw, okay, we saw some kind of a dictionary-like structure with this particular one. Like I said, that's the same replication I want over here. So I have this as a key, and the value is going to be a NumPy array of all the attributes I have over here. So this is a key, and this is a NumPy array of all the attributes. Now, if I'm to do, let's say, y is equal to data sets dot, once again, load underscore cpen. So this is the cpen data. So the iris data is not the only one we have in scikit-learn. We have a lot of them, okay? So if I do dataset dot load underscore cpen, and I'll come and do a preview of y, which is going to be the cpen dataset. This is just, these ones we have just 2 values, okay, in that structure, like a 2x2 array. Over here we have 3 values, okay? So this like a 3 by whatever array. And then we have some target names over here. So over here, the thinking I did, okay, with regards to this, okay, now I want to have a data set where, like, let's say I have, so these are the feature names. So the first column is going to be for width, the second column is going to be for age, and the third column is going to be for height. And now the target names are what I see over here for male and female. So there's like a classification thing. So all the males are going to have 1, and all the females are going to be represented by 0. Just to show you that some of these things are just code people wrote, okay? And it's a very simple thing. I'll share the document with you so that you can do a preview of it. But then the old things that we used to see in KBTCal is still there. So for instance, if I'm to say from, let's say, import KBTCal, okay? I mean, I still have that import. And if I'm to say KBT dot, I've even forgot, so add num is good. By passing 4 and 7 and run this, I'm getting sum is 11. We saw this earlier on. Okay. Now, let me conclude on this scikit-learn thing. So I'm going to say from sklearn import preprocessing. So there's a function in there called preprocessing. And that preprocessing is what we are going to use to do some label encoding. So now see what I'm going to do. Now I've imported this and now everything looks good. So I'm going to use this to do some label encoding. So now let me say I have some data over here, and this data is going to be a NumPy array. So I'm going to say mp.array, and let's say I have something as funny as this. So let's say I have some countries, okay? So I have Ghana, I have Nigeria, I have Ghana again, I have Togo, and we can go on and on and on. But then we want to have a system where, okay, all the Ghanas we have in there will be changed to one categorical data. So if all the Ghanas are 0, we expect to see something like this. At the end of the day, if we do a preview of this, we expect to see, let me put up a comment over here. We expect to see, I mean, things might change, but then we expect to see all the Ghanas being of one particular category. Let's say 0 this way, and Togo will now be 2 because we'll count forward. Okay. So now let's just do a printing of the original NumPy array, which is this, as we see over here. Now we are going to use scikit-learn to do the pre-processing. We could have done it manually, but then if we have about 1 million instances of data with Ghana, Togo, Nigeria, Togo, we cannot be changing that all the time. It is going to be a complete waste of our time. We can do pre-processing over here. So over here, what I'm going to do is, yes, I'm going to call this pre-processing, okay? So I'm going to call this pre-processing dot, and then there's a label encoder over here. Later on, when we start building, how do you call it? machine learning models, you are going to see this label encoder very well so that we convert from whatever to whatever. Now, what I'm going to do is I'm going to call this encode. So I've created an object over here, and I'm using this pre-processing to now get some label encoder so that I encode these labels. So anytime my system sees Ghana, it doesn't just see Ghana, but it has converted Ghana into some numerical or categorical value. So when I do this, this one looks good. So now it is this object that I'll be working with. So now I'll do encode dot, and this time around, I want to do fit over here. What do I want to fit? Excuse me, I have a call. Let me just, oh, I'm so pretty here. Hello. Yeah, good morning. Yes, please. Hello, please, can you hear me?
Yeah, we can hear you. You went off briefly.
Okay, yes. Okay, so we are going to use this fit, okay, to do the encoding. Now, the question is, what do you want to fit? Okay, we want to fit this NumPy array, which contains a lot of data. Okay, so now let me call this y. So y is going to be equal to this. Now, y looks good. Now, I'm going to do y dot, and I'm going to say transform. So if I do y dot transform and run this, it says it's missing. Okay, so y dot transform, and I have to pass in the data as well. So when I run this, everything now looks good. So now see what we have. We have the 0 for, I mean, it's just showing up as 0, but then I intentionally had to write it here so that you actually have a clear view of this. So all the Ghanas, okay, is going to be represented as 0. Nigeria is having 1 over here. The next Ghana is having 0, and then Togo is having 2. Now, if I'm to do another, for instance, Nigeria over here, another Togo, another Togo again, I'm expecting to see a 0, 1, 0, 2. Nigeria is still 1, okay. Togo is 2, and this is also going to be 2 because it is Togo. So now let me run this once again, and now that's exactly what we see. So we can get a 0, 1, okay, then we have a 0 again, then 2, then the 1, and then 2, 2. We don't have to even worry about cross-checking. It is actually going to do a very good job for us. And by this, we are going to do some label encoding. There are other encodings that we are going to carry on along the way, but I think this is the one that will make most sense. So what I'm going to do is I'm going to share this document with you. And what I want you to do is now to go with, definitely when you generate the random data, okay, based on the code that we have over here, we are going to have different values, but at least you are definitely going to have some green.
We are Ken, we are going to give assignment. Don't worry.
Okay.
When we finish, we'll give assignment. Some simple
Okay.
assignment.
All right. You are definitely going to have some green, some yellow, and that. I want them to be some categorical data. Okay. You can leave the fruits for now, but then the colors, let's have some categorical data for colors, and we can use the label encoding over here to actually get that done. Very simple. And we can, I'll not spell it out yet, but then there's a simple way you do it, and then you attach it to the original data frame. Okay. And it's going to be a very simple process for us. Okay, so I think our time is up. And there are some few things I have over here. So hopefully on Thursday, when we meet, God permits, I'm definitely going to touch on the data visualization, and then a few other things that will cover for some finding the class imbalance and other things. Okay, that's going to help us, and then we'll go straight into some feature engineering. In fact, what we just did was a little bit of the feature engineering because it is quite broad, depending on whatever thing you are trying to do. Okay, Dr. Mills, I think I will end it here for today.
Okay, all right. Yeah, so please, do we have any question? Are there any questions so far or comments? Any question or comments? Okay, if there are no question or comment, then I presume everything has gone well. I presume everything has gone well. So now the next step that we are going to do is this. In the previous groups, what we try to do is, in fact, one of the things that I did was we try to look at fruit exports outside to Europe and America. It's food process related project. So I try to look for the international standards. If you are exporting, for example, mangoes to US, what are their requirements? So that we can use machine learning to see if we can do those sort of things. That is at that level. And if you want to go further, then we now have to go through passing it through a machine system so that it will do the sorting for you. But for now, something similar to what we are trying to do now. What I want you to do is, the basic one is, I showed, Ken, do you want us to continue with the flower thing, or I want them to look at the students that I just showed on Excel spreadsheet? We are going to have students, 100 students or 200 students, age range between 18 up to 26 or 28, and then their score for a course between 0 and 100, and then their agenda, and then by department, 5 departments, and their GPA.
So I think we can look at both if we have time, but then maybe the student data will be quite interesting because that's what you are going to work on.
Yeah, because there is something that for the average, we already have something that is there already.
Yeah.
And so something to let them see how they can go around it.
Okay.
Yeah. So you are not going to use, of course, you can use Excel and then import, but what we want to do is follow the same thing, that the coding system that he has, the Python code that he has explained to you now. So that then from there, you can now do the labeling. So that we have the females, we label them. Then we have the department also, we label them. So we have 2 categories or 2 string sets. That is gender and then departments. And then we now have, so this is what I want us to do. This one. So you are going to have a student from, but if you wish, we can even add on, instead of the student name, we can make student ID. And then you generate ID up to, so I want to make it a little bit more realistic. So you generate the IDs from this ID from first student number 1 all the way up to number 200. So I'm going to generate 200 data set. Please, are you listening to what I've said?
Yes, sir.
Yes, sir.
So we are going to generate randomly 200 samples, records of students, and this is going to be ID. Unless, of course, we want to make it simple. If we want to make it simple, then student, this is a spelling wrong, spelling mistake. Student number 1 all the way up to student number whatever. Okay. So that we up to 200. Now the age ranges, we are going to have age range from 18 up to 26. And then, so you see that anytime I do something, because I have not seeded this, anytime I do something, the random number changes. Then you're going to have exam score from 0 up to 100. And then gender, male and female. And then department, 5 departments. The same department as we have in the, we use this acronym A-Gen, B-Men, C-Pen, F-Pen, and then M10. And then we look at the GPA. GPA is from 0 up to 4.0. But I know the university say if you get GPA of below 1, you are kicked out. So we are assuming that people will not be kicked out. So we are assuming that people are going to start from 1.0. (18 to 26), and then the score for the course for the ML program 0 to 100, and then gender, and then 5 departments, and then the GPA, or maybe let me call it GPA. It's okay. GPA or CGPA, any of them is okay. GPA. Right. So we have 1, 2, 3, 4, 5, 6. 6 rows, 6 columns. And then when you are done with the data, then the next one is that we will now do the labeling from what he has just explained to you, the labeling for the gender, and then the labeling for the department. So that if we want to now classify students by department, it will be easier. If we want to classify students by gender, it will also be easier. Okay. So on that note, we end the program for today, and we'll meet on Thursday. We will share whatever has been done with you on the platform.
Sir, please can I ask a question?
Please go ahead. If there's any question, please go ahead.
You said the seeding, with regards to the seeding, does it basically mean storing the random values you've generated so you can reuse those values?
No, in terms of the seed, see that the information that I explained to you, I think the other time we were trying to look at the Python also has this seeding function. No, the seeding function is just something, it's a number that helps that anytime you are generating, it will go back to that number and make sure that that number that is used is what to, you see that this is the whole idea. The number generator process is linked to your processor time. That is what it is. So if the next 5 seconds you generate again, it will use the current time to generate for you. But if you use a seed, that seed is kept, in the case of what I showed you, it is a X0. So always S0 is fixed. And that S0 is going to use to do that. So when you are getting the number, we can say, okay, I go to random number 1 or random number 2 or 3. It's just now a code that is used to reference that random generating process. Maybe next time when we meet, I can show you something also in MATLAB also. It's random generating, how the seed is also done. So what you are trying to do, see that he told you uniform, and there is also (0 to 10), you can generate and multiply by 10. So that in that case, your decimal numbers can also be there at the same time. Please, are we okay on this?
Yes.
Yes, sir.
Okay. All right. So we meet on, when you are done with it and you come, I will get a volunteer to take us through what he or she has done. And then we will also go through again with you on that. All right. So we see ourselves, God willing, next Thursday, this week Thursday.
Okay.